So I think I'm slotted for the whole morning. We got like 4 hours together. I'll throw some breaks in there and whatnot. But I would also encourage everyone to just unmute and shout out questions or comments if you have them. I'd much rather have this be just kind of an interactive discussion than just me talking at a webcam for 4 hours. So with that, what I'll do is I'll just kind of start by sharing the slides, and we'll go into some of the topics of web app security. Maybe I'll start though with just I don't know if I don't necessarily think everyone needs to go around and introduce themselves, but if anyone have any experience with web application security? Has anyone done any exercises, or maybe participated in like bug bounties, or like looked at tutorials online or anything around like web application security hacking? Just curious what kind of everyone's comfort level is with web app security.
Hey there, I haven't been doing any of that, but I am very interested in learning more about those topics and knowing exactly where to start. The first thing I started looking at was, it's a Linux distribution, Linux Kali, but
Sure.
I
Yep.
still haven't had a chance to really use it yet. It's a lot of, I haven't really figured out how it works. I'm definitely interested in learning more about those topics.
Yeah, Kali Linux is a distribution that's kind of targeted specifically for pen testers. And so out of the box, when you install Kali Linux, you get a whole slew of security tools, covering everything from like network security to web application security to reverse engineering. It is an awesome starting point. Even just loading up Kali Linux and clicking onto all of the tools that come preloaded and just kind of reading about them, you'll learn just clean information from what the tools are and what they're doing. The company behind Kali Linux, a company called Offensive Security, they also have a training and certification program themselves. So I don't know if you've ever heard of a certification called the OSCP, or Offensive Security Certified Professional. That in the security industry is really highly regarded as one of the more technical and challenging certifications that you can get. And it's entirely based around Kali Linux. The final exam for the OSCP is actually 48 straight hours, and you drop into a network and you have, I think it's five machines that you have to hack into, and you have to get into all 5 of them within 24 hours. Then you have another 24 hours to write a report. And if you do it, you pass and you get the certification.
That's crazy.
So
That's cool.
yeah,
That's
if any of you are interested in pursuing careers in penetration testing in particular, or other areas of security, that's a great training course and certification. But yeah, so I'm happy to hear that that you're familiar with Kali. If anyone wants to talk more about that, or maybe after this workshop, other sort of trainings or certifications, definitely more than happy to help out there. All right.
Are you in our Slack? Can you add like a link to some of these things, maybe?
I am not in the Slack, no.
I can get you added there.
Okay, yeah, maybe during one of the breaks or something, if you want to just add me, I'll fire up Slack, and then, yeah, I will share that out. And then, yeah, at the end of this workshop, I'll definitely be sharing out the slides so everyone can have those as a reference. And I think this is going to be recorded too, so you feel free to reference back to this and share it amongst whoever you want. All right, I'm going to fire up and share PowerPoint here, and we'll kind of jump into it. Okay, does this look okay for everyone? See the slide?
Yep.
Cool. So like I mentioned already, the agenda for this workshop, what I'd like to do is first just kind of do a little intro, a little bit more on me and OWASP, one of the organizations that I'm here representing as well. And then I'm going to start with just high-level security concepts before we get very technical, or before we even get really like web app focused. There's terminology in the security industry that I think is useful to be familiar with, and just understanding like how to think in security terms before we dive into like web application specific security. And then we're going to go back to basics. I looked at the curriculum and that was shared with me on what you guys are learning, and it's really awesome stuff that they're teaching you. But I want to make sure everyone kind of has the same foundational knowledge. It's really important when we start talking about these security concepts that we actually understand like how these technologies are working and interacting with each other. So this might be review for some of you, but I think it's probably going to be valuable review for us to go back to like web app and HTTP basics and just cover some of the technologies that are in play. And then I'm going to talk about just some of the common web vulnerabilities that we see. And there's a lot of them, but I've decided to kind of focus on three or four classes of vulnerabilities that I'm going to try to explain conceptually, and then show some code examples of like what causes these vulnerabilities, and then hopefully explain how we can exploit them and why they're bad. And then at the end of that, there is a hands-on lab where actually all of those vulnerabilities do exist, and I'd like everyone to kind of hopefully get their hands dirty of identifying and exploiting those vulnerabilities to get that practice in there. And like I mentioned already, just shout out or unmute if you have any questions. We don't have to wait. I'll sprinkle breaks in here, or hopefully some natural breaking points for us to get some coffee and whatnot. But if you have any questions or comments, just shout them out. So like I mentioned already, I work for Motorola Solutions. I am the application security lead there. Prior to Motorola Solutions, I was also an application security lead at a company here in Chicago called Uptake. And then prior to that, I spent the first half of my career in consulting. So I actually started my entire career in security. I have never actually been a professional developer. I didn't go to school for any computer science or development. I just found this niche industry called penetration testing, where I figured out that I could get paid to hack into things and loved it and just ran with it. So I was a penetration tester at a company called NeoHapsys, which was then bought by Cisco, and did that for a long time, and still absolutely love penetration testing. If you're not familiar, penetration testing is really just ethical hacking. Companies would pay me or my team to try to hack into whatever they were trying to defend, whether it was a web application or their network or a mobile application. And we would put on our hats like we were real hackers. We'd try to identify everything, we'd break in, and then we'd develop a report and say, here's how we did it, and here's how you can fix it. And so I did that a lot. I actually started off doing network security assessments. I had a specialization in like Windows and Active Directory, but even 10 years ago, really started to notice all the demand was coming in for web apps. Everyone was building and developing web applications, and there was strong demand for web application security. And so out of just sort of necessity, I learned a lot of web application and web application development, and then really started to specialize in that. After doing pen testing for a while, I'll be honest, I kind of got tired of just constantly breaking things and never actually building them. I'm an engineer at heart. I actually like to be building things and developing things. So that's when I shifted gears and ended up working with a company like Uptake or Motorola Solutions, where I'm on the engineering side. I do still have this knowledge of pen testing and how to break web applications and how these vulnerabilities work, but I much prefer to actually work with developers and help them design and build better and more secure web apps, or when we identify these vulnerabilities, how to fix them. I am on Twitter. My handle is Ropnop, R-O-P-N-O-P. I also have a GitHub repository where I publish some open source tools, and I blog occasionally as well, blog.ropnop.com. So you can find me online as Ropnop, and I think my email was also in the first slide. I'll share that out as well, rflathers@gmail.com, if anyone wants to just reach out. Who's heard of OWASP before? Just curious. Quick. All right, I see a few hands going up. So OWASP is another community that I'm heavily involved in, and is actually what precipitated me coming to give this presentation. I think Code Platoon reached out to OWASP, and OWASP reached out to me. So OWASP is the Open Web Application Security Project. It's a global foundation, it's nonprofit, and it's really just a lot of, it's a group of very like-minded developers, engineers, architects, security professionals with a common purpose of just sharing knowledge around how to make web applications secure. So OWASP has amazingly valuable resources, tools, trainings, and it's all free. There's the OWASP.org website, which will link to all of this, but OWASP publishes tools, documentation, provides trainings for free, just really for the greater good of making sure that developers know how to make secure web applications. So there's a couple resources that I've linked here. OWASP has a lot of different projects, but these are probably some of their more popular ones. The OWASP top 10, I'll definitely be talking about later, but OWASP actually publishes a well-known top 10 list of the top 10 most critical web app security vulnerabilities. OWASP ASVS, or Application Security Verification Standards, is used by a lot of organizations, including my own, for kind of a checklist approach to web application security, or making sure that each application abides by these standards. The Software Assurance Maturity Model, or OWASP SAM, is also used by a lot of organizations to kind of just rate how we are as an organization and our strategy around software assurance and security. And then ZAP, I'll also be talking about, or the Z attack proxy, is a really cool tool that's used to dynamically scan web applications, or can be used to test web applications. OWASP also has some conferences. There's a global AppSec conference that happens every year. This year it's happening in San Francisco, hopefully in person, but likely at this point probably going to go remote. And so there's the global AppSec. But the big thing I think for all of you, sorry, I should have even asked, are most of you Chicago based or everywhere? No? Okay.
Like everywhere.
Got it. Okay. Well, I'm Chicago. I would say check out OWASP.org, because there's actually chapters in a lot of the major cities. The Chicago chapter is great. That's the one that I'm heavily involved in. So we meet once a quarter, once every other month or so. Some chapters meet very regularly, and there's great speakers and tools and networking events going on there. So you can find your local OWASP chapter, whatever city you're in, and get involved. All right, cool. So like I mentioned, before I get kind of technical and start talking about web application security, I wanted to just talk a little bit about security in general and some of the high level concepts of information security, and then we'll dive into how it applies to web application security. So I want to start with this quote, or it's a tweet from a gentleman named Jim Manico, who's also really involved in OWASP. He sits on the OWASP board, and he's a really versatile trainer and speaker in security. And this is his pinned tweet, or he put this quote out there, but I absolutely love it, and I just want to start with it. He says, "From my experience, all software developers are now security engineers, whether they know it, admit to it, or do it. Your code is now the security of the org you work for." And I really think that's so true, and I can't drive that point home enough. Like I mentioned in the beginning, knowing security or knowing part of security is really almost an expectation now for people pursuing careers in software development. There's no such thing as the siloed security organization or siloed security team that sits by itself and is only specialized in security. We expect everyone and all developers to know security, because they really are the front line of defense. If you join an organization and you are a software engineer and you are developing code for that organization, Jim is right. That code is the security of the org you work for. So whether you know it or not, you are a security engineer. And so these security concepts are really, really important to understand. And it's becoming even more evident in this kind of the shift to DevOps and this whole world of DevOps now, where as a developer, you're also doing operations. You have complete total ownership of your code from start to finish, from every cycle of the software, every phase of the software development lifecycle. Developers are owning code end to end, and security just naturally fits into that. I have advocated in all the orgs that I've worked with in the past that there really should and cannot be this concept of these like security team that sits in a high ivory tower and looks down at the developers and throws findings down there and says, fix this, or you can't do this, or you can't do that. Like, that model doesn't work anymore. And just as DevOps has kind of blended this responsibility matrix between developers and deployment engineers and operational engineers, well, security engineers are getting thrown into there as well. So my team at Motorola Solutions, I call us enablers. We are a application security team that needs to work with developers, and we want to enable all of the developers and all of the engineers to implement security and to do security right, but we actually aren't the ones doing security ourselves. And I wish I could say that's the model how it is everywhere. Some organizations still follow what I would call this old mindset of security is a very specialized field and we have to hoard all the knowledge and we're just going to throw out yes and no's when we need to. but they're going to fall behind the times and get with it eventually. This is how it's going to be in the future. This is how it should be. And if you're going out and starting your career as software developers or joining an organization, you're going to end up working with the security team, and you're going to need to know some of the security concepts of your code. So I mentioned working with the security team, and if you work with security professionals, they'll start throwing out terms, and security kind of has its own language. And so I wanted to put this slide up here to kind of explain a little bit some of the common terms that you might hear if you're dealing with security professionals, because there's subtle differences between some of these words, and especially if you're talking with a compliance professional or someone maybe in a security capacity but not technical, they'll start throwing out all these terms, and it's kind of important to kind of map them to what we're doing as software engineers. So the first big one that is thrown around a lot is this triangle over here. It's called the CIA triad. I'm not sure if anyone's heard of this before, but in a lot of security circles, this is how risk is assessed. When we are designing a system or designing an application, there's three things we always need to take into consideration: confidentiality, integrity, and availability. And all three of them, or the CIA triad, are what we kind of rate our risk against. If we're making an application, if we're making a web application, we definitely need to make sure that confidentiality is important. So, we don't want data to leak to people who shouldn't see it. Integrity is important. We want to make sure that we can trust the data and it hasn't been modified. And then, of course, availability. We need the service to always be up. And what you'll see in a lot of organizations, or depending on what system or application you're designing, some of these are more important than others. So I can tell you from experience, I work at Motorola Solutions. What we make, the products that we make, are the high-end radio equipment for first responders. We design the systems and the applications and the networks that power the radios that police and fire and EMTs use. In our world, in the CIA triad, availability is number one by far. We would actually sacrifice. Of course, we wouldn't want to, but if we needed to, we would sacrifice confidentiality or integrity over availability because our services cannot go down. So you have to kind of sometimes make those trade-offs if you're designing an application. What's the most important to you? You'd love to have all three of them, but sometimes, depending on the context, one is more important than the other. The other terms that kind of get thrown around a lot are vulnerabilities, threats, risks. And these all do have kind of subtle differences. This chart here is kind of a good visual representation of who owns what and protects what and patches what. But really what I'll be talking a lot about today, and I'll keep using these terms, so that's why I wanted to stress it, are vulnerabilities, threats, and risks. There's a big difference between a threat and a vulnerability and a risk. And I'll talk a little bit more about that on the next slide. And if I say a control, in security parlance, a control is just a way that you mitigate a risk. A control can be a technical control. It can be like, I wrote some code and I fixed it. That could be a technical control. It could be a detective control, like we're just going to watch the logs and monitor it or detect it. Or it could be a physical control, like actually putting a lock on a door to a server room, or having a camera. Controls are just anything that are in place to kind of help keep your risk low. So when I talk about threat versus vulnerability, it's really important to think like an attacker. And this is a skill that comes with practice, but it's a really, really valuable skill. And it's why I like to teach these types of classes and teach how to do pen testing and how to actually, hack a web application, because thinking like an attacker really lets you understand the implications of threats and vulnerabilities. So I want at the end of this workshop for everyone to kind of be able to put on like their hacker hat and be able to think like an attacker when you're designing your own web applications, because it'll make you a better software engineer and a better developer. But it's also really important to contextualize everything and be realistic. And this is a problem when just in security in general, is sometimes you can go down the rabbit holes and start thinking about all the worst case scenarios and every possible little thing that can go wrong. But we don't have unlimited resources to fix that. We have limited resources that we need to make security as good as possible. So it's also important to not just think about everything that can possibly go wrong and, oh my God, the sky is falling, but what can we do about it and really how bad is it? And to do that, you have to understand both threats and vulnerabilities. And when you combine a threat and a vulnerability, you then understand risk. And then the equation just becomes how much risk are we willing to take and what can we do to lower the risk. So I find that physical analogs are actually a really good way to start. Before we get into like how are we defending a web application, I think it's sometimes easier to start like, let's say that we are designing a bank and we're actually trying to just build like the world's most secure bank, like Fort Knox or something. If we're thinking like attackers as we're designing this bank, we have to start asking ourselves some of these questions, like what are the threats to the bank? What are the threat actors? What are the vulnerabilities? What are the controls? So maybe I'll pause here and see if anyone has any ideas so we can start a conversation. If I was tasking you with just like, blueprinting out and designing a bank, and it had to be fully secure, right? We had to make sure that what was inside the bank could not get stolen or leak out. The first question would be like, what are some of the threats that we'd have to take into consideration against a bank?
Earthquakes.
Yeah, perfect. Yeah, that's absolutely, like, it doesn't even have to be a threat from a person. It could be just an act of God or an environmental disaster. Like, absolutely, we have to think about earthquakes. That is a threat. And then we have to design a bank that could withstand earthquakes.
Employees working at the bank and what sort of data they have access to, how they could potentially release that to someone who doesn't need to know it.
Yeah, that's a really good one too. Yeah, people are always huge threats. So if we ask like who are the threat actors, the threat actor is usually in our world like a person, but it doesn't have to be a necessarily malicious person, right? We could certainly have threat actors that are like state-sponsored Chinese hackers that are very purpose and mission driven. But a threat actor could also just be some random employee who clicks a link. They don't know any better. Like that could also be a threat actor, and they're carrying out, and the threat could be accessing something they shouldn't have access to. Yeah, those are good answers.
If any of the security features require electricity, having on-site generation for power, as opposed to being dependent on the grid.
Yeah, that's another really good one, and that hits a lot of these, right? So a threat could be like a power outage, like a citywide blackout, and if we tie that into a vulnerability, the vulnerability there might be we're dependent on the city to provide our power, and we don't have our own power supply. So our vulnerability is we don't have our own backup power supply. And you already gave me the control. The control would be, let's put a backup generator in place. So that's kind of how we hit all three of these. We think about what could go wrong, how could it go wrong, and what can we do to fix it. Yeah, those are good ones. Anyone else think of any other vulnerabilities that might exist in a bank and what we could do to prevent them?
I'm just thinking of like sending money that you don't have and ensuring that that money is there. I don't know.
Yeah, that's actually a good one too, because these terms exist also in the financial sector. So if we talk about like having controls in place to prevent like withdrawing from an account or sending money we don't have, there could be financial and accounting controls in place. It could be people looking at balance sheets and doing things by hand, but that's a control that exists to make sure that we don't overextend ourselves and send money we don't have. Yeah, there's lots of them. Other vulnerabilities might be like a safe combination with a weak default password, or a weak default 1234 to get in there, or a door that doesn't lock, or a camera that's turned off. The whole point of this exercise is to kind of you start thinking about this, and there's so much that can go wrong when you're designing a bank. Take that exact mindset when you're designing a web application or you're designing a system. What could go wrong? What do we need to be worried about? What do we need to be concerned about? And what can we do to prevent it? And kind of what we just did here, just talking out loud, is what we call threat modeling. And threat modeling is really just that kind of example process of let's just talk out loud and enumerate the threats to the system that we're designing. Let's identify vulnerabilities, and then let's think about the controls that we need to mitigate, that we need to put into place to mitigate that. So we just did a really quick threat model. I've been involved with threat models of like super sensitive applications that have taken like days and weeks of interviews and discussions, so they can get really in depth. But really, it's the same type of concept. We're just talking out loud. We're looking at our architecture diagrams. We're thinking about how we're going to build this app in this system, and we're asking these types of questions and writing them down. So talking about threat modeling, I wanted to put this slide in here. There's so much out there in the realm of application security nowadays. And for those of you on the call, I'm not sure who's maybe currently working as an engineer or developer or looking to pursue a career as an engineer or developer, but in one way or another, if you join an organization or working with an organization, they're going to need some way to make sure that your code is secure. So how do you make sure that your code is secure? These are probably 5-6 most common activities that an organization will perform to ensure that someone's code is secure. And so I wanted to call them out, but I'm not going to spend too much time going into any of them. The first is threat modeling. So that's kind of what we just did with the bank. The threat modeling is an activity that gets performed, talking out loud, architecture reviews, designing, things like that. Then we get into some of the tools aspect, and these are easily automated, and a lot of times will be automated into the SDLC, tied in with like continuous integration, continuous delivery as your software gets built. SAST is static application security testing. This is kind of like, you can think of it like spell check on steroids for your code. So there's tools out there that can just scan your code as is and identify if there's any potential vulnerabilities. DAST, or dynamic application security testing, is a different approach where your code is already built and it's running, and these tools go and automatically poke and probe and prod the application as it's running and determine if they break anything or if they get past anything. And so it's an active scan against a running application. The next area is kind of a new field, but it's becoming extremely important. It's software composition analysis. There's been some crazy statistics. I should have pulled them. I think it was the NSA published a study and said upwards of 75% of code in all applications now is open source. So if we're writing applications, we're inheriting the vast majority of our code from someone else who's written it. And as an aside, I was kind of preparing for this. I know that you guys are learning React, and so I was creating a React app. And I downloaded like the create React app like starter command. And after installing the dependencies, I just did a quick like count of lines of code, and I had 1.2 million lines of code downloaded to my project before I even started writing like my Hello World React app. And as security people, that's kind of terrifying to think like I haven't even started writing code yet, and I've already got over 1 million lines of code. Are there any vulnerabilities in that code? So open source security is becoming a bigger concern and a really big area to focus on. And that's what software composition analysis does. It looks at what open source we're using and if there's vulnerabilities in code that we didn't even write ourselves. The next is penetration testing. This is the manual, like hands-on aspect where we're going to test and identify vulnerabilities. And this is what I'm going to be focusing on today. It's going to be all pen testing kind of in the lab and from here on out. And then lastly, vulnerability scanning is slightly different than running code, but it's identifying the vulnerabilities in like the network or the infrastructure components. So the servers that are powering the code, or the networks that are like, handling the traffic for our applications. Oftentimes, as developers and engineers, we're responsible for that as well. Because if we're building our code into Docker images, those Docker images could have vulnerabilities, and depending on where we're deploying those vulnerabilities, we may be in charge of managing that infrastructure. So I'll talk about pen testing, and pen testing is an extremely overloaded term. This is a chart that was actually made by an old colleague of mine when we were consulting, because we had so many companies coming to us and saying, I want a pen test, and we never knew what they actually wanted, because it's just a term that doesn't necessarily carry too much weight without context. So when we talk about like doing a pen test, we usually mean like we're doing a manual assessment, not an automated scan. But even the manual assessments can have different scopes and details. The main ones that you'll hear about are either black box, gray box, or white box. And really what that means is just what level of information do we as the pen tester have. In a white box assessment, we have full access to the source code. So we're doing like an in-depth review. We have all the information. There's no mysteries. We're just doing that manual assessment. In a gray box assessment, we don't have source code, but we have more context than like the average attacker on the internet would. So we're more involved with the architecture and understand the application. In a black box assessment, it's really attacker simulation. It's like we don't have any knowledge. We're just going to be like a random hacker on the internet that stumbled across this web app, and we'll see what we can find. And so today when we do the lab, we're kind of going to be doing more of a gray box because I'll give everyone some hints, but you're going to be coming at it from like a black box perspective. Like you're not going to know much information about this app, so we're going to have to find things and glean information from what we can just by looking at it. And so this is why I love teaching pen testing, because knowing how to perform your own web application testing is a really important skill, because you'll actually then understand what real attackers are doing to web applications and what they're looking for. And if we see vulnerabilities and we exploit them ourselves in practice, we can understand why they're bad. But it's also really useful just from a testing perspective. If we ever need to verify findings or debug something in our application, a lot of these tools and techniques don't necessarily have to be purely for like, nefarious hacking purposes. They're really good for debugging and troubleshooting. We'll also find that scanners really are bad at understanding context. An automated tool is never going to know like what's good or what's bad about your app. Like it's not going to understand if I should be allowed to do this or if this is considered normal. That context gets lost when you just run the automated tools. So there's still always a big human element and a human component to actually doing this. And really my goal is I want to empower you all to be able to test things yourselves. As you're working on your next project in Code Platoon, you're building, your to-do app in React, you should feel empowered to actually just go poke at it, try to pen test it, try to scan it yourself and click around and make sure it is secure. That's the best way, in my opinion, to actually be, to learn and to be a really strong and secure developer. But I have to put this disclaimer in here. With great power comes great responsibility. There are, of course, ethical implications when it comes to just like hacking or pen testing or poking or prodding applications, right? You should only ever do this to things you have permission to test. Only test applications that you built and are running yourself. There's even implications you have to think about if you are running an application in a cloud provider. Sometimes those cloud providers don't even want you to pen test their apps without giving them permission or without getting the cloud provider's permission. So it is, sometimes a gray area. What I'm trying to say is just because you learn how to do this, don't go out tonight and just start hitting random sites on the internet or like poking around on your bank website to see what you can find. There's tons of free resources on the internet to let you do this, and bug bounties are amazing grounds to practice because they kind of already give you permission to do this. So if you do want to practice on like live websites, you can actually just go like find what websites have bug bounties, read their like terms and sign up, and you can start like poking away at Facebook or Google if you want, with no implications because they've given you permission to do that. All right, I'll pause there. That was kind of my quick overview of application security and security concepts and threats and threat modeling. Any questions or comments so far? Did some of that make sense? Has some of you been exposed to those concepts before or ever done a threat model before?
I did it a while ago in school for application security course.
Okay, cool, awesome. How about scanners? I don't know if, as you guys are writing your code, have any of you tried to look at any static scanners or run your code through any tools to see if there's quality issues or security issues, anything like that?
Just
yes.
put out from NPM.
Yeah. Oh, would you say NPM?
Yeah.
Definitely. Yeah. I don't know if y'all ever noticed, right? If you do like an NPM install, usually like the last step will say something like you have X vulnerabilities out of date or X packages out of date with these vulnerabilities, right? NPM actually has this ability built into it now to identify vulnerabilities and packages that are out of date, which is awesome. I love that. That's actually that software composition analysis piece I was talking about. So if you're installing dependencies with NPM and you see that you have them, NPM audit fix usually goes and just updates your dependencies and your packages for you. So it's really nice when security kind of gets embedded in the tool chain like that and gives you immediate feedback.
I noticed GitHub is doing similar stuff to your repos now too.
Yeah, I love that too. The whole Dependabot now, like GitHub will scan your repo. I've gotten alerts on my repos before from GitHub. It says, hey, you're using this library. This library just had a CVE drop. You should probably update. I'm like, that's awesome. I didn't even do anything. Like GitHub's now just proactively telling me my code's vulnerable. Yeah, it's really cool. I'm excited to see where all this stuff goes, I think. Cool. Well, all right. I'm going to breeze through this web app basics, and then maybe we'll take our first break. So like I mentioned earlier, this is kind of going back to school, Web 101. This might be review or elementary for some of you. I know you've been in this cohort now for 10 plus weeks and have been learning web application development, but I wanted to put this in here, and I like to always start with these types of topics before we get into more advanced web security, because it's really important to have some like foundational knowledge about the technologies here. So I've found, being both on the teaching end and on the receiving end of security education, that a lot of the web app security education just jumps right into the attacks themselves, and they'll just talk specifically about the attacks and how to defend against the attacks and how to exploit the attack, and they kind of gloss over like why the attack even works in the first place, or what I consider to be like the security principles. And that's why I try to take a different approach, where I'd like to rather talk about some of the security principles that exist, and then we'll understand why the attacks work. And if you understand that concept, then you'll do a much better job of designing secure applications or fixing applications. Because far too often, and I've seen this in a lot of organizations back when I was pen testing, that fixing security bugs is kind of like whack-a-mole. Like one comes up and a developer takes the task off Jira and he fixes it, and then the exact same vuln pops up in a different area, and you go over there and you take the story and you fix it. When really it's like if there was a clear understanding of what the root cause was of this vulnerability, we could do work to eliminate it across the board. And even very experienced developers and security pen testers like mix some of these security web app concepts up, things like cores and CSRF and cross-site scripting, which we'll be talking about. So my hope is, as we go through this, that by understanding like why these attacks work and what security principles they're based on, we can all learn how to defend against them and think about that when we're working on our apps. All right, so this is the overview part. Making sure we have some of our terms and definitions correct here. So the web is made up of a couple core technologies, and they all interact together, and they're all different, and we have to just make sure we're using the right terms here. So HTTP, when I say HTTP is the protocol. HTTP dictates how data gets transferred, and it's a plain text protocol that powers the whole web today. It is a very well-defined and strict protocol. There's very specific keywords. There are accepted verbs and headers, right? Things like get, post, put, patch. These are like actual HTTP verbs that are defined in the standard spec. And HTTP is generally over TCP, which is the layer down protocol, and generally over ports 80 and 443. So if you hit your website over http:// it's port 80. HTTPS is HTTP secured over TLS. That's done over TCP 443. So HTTP itself is just the protocol. It just defines how data should go from one point to another and the format that it should be in. HTML is a markup language, and it describes to the browser how to render the page. HTML is not a quote-unquote programming language. It's not a complete language. You can't write a really advanced app or any sort of logic in HTML. It's just a format, again, for displaying data. It's really not any different than something like XML or JSON. It's just a way to structure data, and browsers understand HTML, and they'll display HTML. CSS I don't really talk about too much, but CSS is just the style metadata that's associated with the HTML. Tells the browser like what colors things should be in, what positions they should be in. So you usually see HTML and CSS come side by side. The browser takes both of those and puts a display, right, renders the page for us to see. And then in web app security, this is an important term I'll use a lot, the DOM, or the document object model. Have you guys talked about the DOM? I think you were just getting into like React and some client-side stuff, right? This is the DOM plays a huge part in client-side applications. But what the DOM is, or the document object model, is what the browser constructs from the HTML and the CSS. So what you're viewing on your page when the browser loads is the DOM. And the DOM is ultimately, right, what gets clicked on, it's what gets interacted with, it's what gets displayed to the end user. So visually, it kind of looks like this. If HTTP comes in, the browser parses the HTML, it parses the CSS, it constructs and prints out the DOM, and the DOM is what we see with and what we can interact with. The one big thing that's missing from this diagram is JavaScript. So in the world of web, JavaScript is king. Really can't overstate how powerful and ubiquitous and important JavaScript is in all of this, because JavaScript is, as opposed to HTML, a complete programming language. You can do anything with JavaScript. It's a fully functional language. And browsers have their own JavaScript engine that executes loaded JavaScript code. And JavaScript has full read and write control of the DOM. And so this is why modern web pages or modern single page applications with React are like 100% JavaScript. And all they're doing is just using JavaScript to manipulate the DOM, which changes what we see and what we interact with. JavaScript also has full access to browser storage, has access to all of our cookies. And depending on the browser and how modern the browser is, right, it talks to all the browser APIs. So browsers expose APIs to interact with the webcam, with the microphone, to get your GPS location. JavaScript can access all of this, and it just talks with the browser. And the browser executes JavaScript in a sandbox to limit its power. So this is our first kind of security principle or security primitive here is browsers have a sandbox because JavaScript is so powerful. They have to try to limit what it can actually do.
Is that why when you open your task manager, some browsers have like 6 applications running?
Yep. Yeah. So absolutely, like Chrome has a really strong and robust sandbox, and that's probably why you see like Chrome hogs all my memory and all my CPU, and I end up having 100 Chrome processes. So Chrome opens every single tab in its own process, gives it its own memory space, and then executes JavaScript within that tab within its own sandbox environment. So it's kind of like shielded layers of defense that Chrome is taking to prevent JavaScript from being too powerful. And sandbox bypasses or sandbox escapes, those are the types of bugs that like you can sell to Google for $1 million or probably $100,000. So those are the types of ones that are like really, really bad. So HTTP, if you haven't like looked under the hood before of a web application, right? HTTP, because it's plain text, it's really easy to just like see and write and read. So HTTP is plain text, and this is really important because everything is in ASCII, and it uses common words and verbs and the English words and verbs. And the other important aspect of HTTP is it is stateless. And what I mean by that is there's no concept of like an open or shared saved connection between a server and a client. Every single HTTP request that gets sent to a server has to be completely quote unquote standalone. Servers have no memory of like things they've sent or received in the past by default with HTTP. So HTTP, as opposed to some other like network protocols, is considered stateless. And this is really important when we start talking about like cookies and state, which I'll get to. But this is what HTTP looks like, right? This is just a terminal. If you want to, you can talk to a web server with plain text. I can just open up a connection to Google on port 80. I can type in some valid HTTP like get / HTTP 1.0, and Google will respond to me with HTTP. And HTTP is split up between headers. This information goes to your browser, and your browser does things based on what's in the headers, and the body, which is usually HTML. And the browser understands HTML and parses it and builds the DOM. So because HTTP is a plain text protocol, like certain characters have to be encoded for it to work properly. Things like new line characters have a very specific meaning in the protocol. So if you want to send a new line character, you can't just send the new line character as a new line character. So you have to encode it. Really important thing to note, because this mixes people up all the time. Encoding is not encrypting. When we talk about encoding something, there's zero security associated with that. Encoding something is just changing data from one format to another. Doesn't give you any security benefits. So don't try to use encoding because you think you're hiding something or you're being more secure. There's no security when it comes to encoding. And when we see in web apps, we'll see lots of different types of encodings. And it's useful as pen testers for us to just be able to identify it on site and kind of be able to know at least what kind of encoding it is. So if we're talking about hello world here, this is the plain text ASCII string, hello world and exclamation mark. This is equivalent in different types of encodings. We've got URL encoding, HTML encoding, ASCII hex, base 64. And a lot of times only the special characters are encoded. So here's like a mix of plain text hello, but the space and the exclamation point are HTML encoded, sorry, URL encoded. All right, so like I mentioned, HTTP is a stateless protocol. So servers have no way of remembering or determining who they are talking to. Every single HTTP request that a server gets, it has to accept, and then it has to make a determination about whether I've seen this person before. And that was how HTTP was invented. That's how the web worked for probably a couple of years until someone had a brilliant idea to bolt on cookies. And cookies, in my opinion, are kind of just a hack that was not considered in the initial HTTP, but was born out of necessity to handle and state, to basically bolt on state to HTTP. So when browsers, servers can send a cookie in an HTTP header, browsers will remember that cookie, and then browsers will automatically send that cookie on future requests to servers that match the domain. Cookies are usually an identifier used to correlate a client state on the server side. If you're using Django on your server app, there's Django plugins, or I think Django out of the box comes with like session management with cookies. Usually what's going to happen is for each user, like after they log in, a cookie is like a unique identifier that gets sent with every subsequent HTTP request, and the server knows that that identifier correlates with that user. It's also used for, I'd say sketchy purposes, right? Like cookies are all over the web and just used for tracking clients. Like Google's ad cookies are all over my browser and they know what sites I'm visiting. So there's some like sketchy ways that cookies can be used. But really cookies are just all about remembering, so servers can remember who the client is. And browsers are really helpful, quote unquote, because they'll send any matching cookies automatically with every request. And this is kind of problematic, and we'll talk a little bit more about that later. There are some flags to improve cookies security. So if you see these flags get set with your cookies, there's a reason for them. HTTP only eliminates how JavaScript can interact with them. Secure means only send them over HTTPS and never HTTP. And then same site I'll talk about at the end is a new flag that not all browsers support, but it's a great security feature. Besides cookies, if you're doing any sort of client-side programming, you'll probably be exposed to browser storage, which is different than cookies, but it's another way for client applications to save data in a browser. So you'll see references to like local storage or session storage. And these are just kind of arbitrary like in-memory databases that the browser has for you that you can save data into. And oftentimes like big single-page apps with React or Angular won't use cookies, but they'll use local storage or session storage to save data. One thing to kind of note is cookies are scoped to a domain, but they're only available to JavaScript within the origin. And browser storage is isolated entirely by the origin. And I wanted to throw that out there for the term origin because I'm about to explain that. That's a really important security concept with web apps and browsers is the concept and the term of origin. Some other reviews, just how do browsers make HTTP requests? There's two distinctly important ways that browsers make an HTTP request. Like how does a browser just go out and automatically fetch something from a server? There's the quote unquote traditional way. This is just pure HTML. This is like baked into how HTML and browsers were initially designed to work. So here's some examples of when a browser automatically makes a request, like when a page loads. If we link a style sheet, or if we link a script, or if we link an image, or if we link an iframe, these types of HTML entities will automatically cause the browser to go out and request hello world.css, hello world.js, etc. Some of the others require an event like a user clicking, right? So if we have an href and an a tag, that's a link. If you click on it, the browser will actually go fetch google.com and change the browsing context. Likewise, if you have a form, you can submit it. If you hit the button, it's going to submit something and the browser is going to send the requests. This is the most important thing to know, is these types of requests from the browser include cookies automatically. That's where the browser is very helpful and will just send whatever cookies it has. And there's not really a technical term for these, but I call them HTML requests because they're usually triggered through HTML elements. The other type of HTTP request that a browser can make is the JavaScript way. And so early on, browsers exposed an API that let JavaScript also make HTTP requests, and that's the XML HTTP request API. On modern browsers, there's the Fetch API now, which is basically the same thing. And this lets JavaScript that's running inside that sandbox make HTTP requests, and it will do it silently in the background without notifying the user. And this is kind of called AJAX programming, or asynchronous JavaScript and XML. This is what modern web is now. This is just, big modern single page applications in React or Angular, and all they are is a bunch of JavaScript, and all these requests are happening in the background of the page without user interaction. So these, though, are subjected to what's called the same origin policy. And so these do not have cookies sent automatically. And there's a couple other security things the browser does to make sure that these JavaScript requests are good. So all of that is to kind of just bring me to this idea of the same origin policy. And the same origin policy is like the backbone of internet security. And not all, but a lot of web application security vulnerabilities are all about just bypassing the same origin policy. So who's heard of the same origin policy? Maybe you've come across it. It's probably like if you're doing APIs or seen some errors with cross-origin resource sharing or anything like that.
I've had it a few times on when setting up AWS bucket.
Oh yeah. Yep, you have to
It's
exactly.
always the thing that I forget to set on the bucket, and it always denies all of my attempts to get a resource.
Yep. Yeah. So it's funny. Most people's experience with the same origin policy is like frustration. They're like, oh, I hate the same origin policy. But it's like the most important thing keeping them secure on the internet. So it's kind of this like love-hate relationship. Or if you don't understand why it's good, then all you ever see, is the errors that it causes. But the same origin policy is this. Basically, any site that you visit on the internet can load and execute JavaScript in your browser. And this is a pretty big security concern. And browsers recognize that we can't just let any site execute any code on our client machines. So they did that by limiting what JavaScript can do. We already talked about sandboxing, which is like what Chrome does with different processes. But the other big powerful thing they did was implement the same origin policy, which basically says that JavaScript should only ever see and access data associated with the origin that it was loaded from. So here's my example. If we have www.example.com, and JavaScript gets loaded from our website here. This JavaScript is super powerful. It can manipulate the DOM, it can talk to storage, it can talk to the APIs, it can read and write cookies. But the one thing that it cannot do and should never be allowed to do is do any of that on chase.com. So the browsers implemented this sandboxing feature called same origin policy that says anything that's associated with like a different website, we cannot let JavaScript talk back and forth between those websites. So within chase.com, JavaScript here, fully powerful. Within example.com, fully powerful. This cross communication between origins is expressly forbidden by browsers for very good reason. That's kind of the next level of sandbox that they've implemented.
Is that the reason why we'd have like an API key? Is that what kind of, because I'm just thinking like when we pull data from somebody else's site using their API interface, looking at the picture here, it looks like we shouldn't even be able to do that. So is that where the API key kind of comes into play to allow a known bridge to occur?
Sort of, yeah. It's actually like a layer below that. So API keys are generally for like authentication, to make sure that I as a user should even be able to see the data. When we're talking about APIs and like exposing things publicly, there are ways to loosen the same origin policy. And this is at the very end of the presentation. If I have time for it, we can talk more, but that's called a cross-origin resource sharing. And so there's ways that you can configure, like the gentleman who talked about configuring his S3 bucket. You have to configure your server to allow some of this traffic if you want it to be publicly exposed. So this is kind of like the by default, this is how it should be. In practice, there's lots of like little bypasses that can go on here, but you have to be the one to expressly configure that. So I wanted to throw this in here because like, why is same origin policy good, right? Without it, the web would be like the Wild West. It would be insanely dangerous. Imagine like this little HTML page here is like my attacker, and I host this on my website. And you land on my page. So I will just immediately kick off a bunch of JavaScript that is going to talk with chase.com, where your bank is, and transfer money. And then I'll talk with Amazon.com, and because you're logged into Amazon, I'll go ahead and buy myself a MacBook, or et cetera, et cetera. Like this is the kind of stuff that would be possible without same origin policy, because I can execute my code in your browser and just make your browser do things for me. So this is why same origin policy is really important, because if you land on attacker.ropnop.com, the only thing I can actually do is interact with attacker.ropnop.com. I can't talk to Chase. I can't talk to Amazon. So I've mentioned origins a couple of times now, and origins have a very specific meaning. And so this is it's kind of maybe an unfair quiz if you've never done anything within the space before. But let's say assume that JavaScript is loaded from example.com /home/homepage.html. Which of these resources are considered to be the same origin? So my JavaScript loads from this URL. What can my JavaScript actually talk to? Of A, B, C, D, or E. Throw out, if you have any ideas, throw them out. What was that?
B and E.
B and E?
Yes.
Okay. Anyone else?
Just D.
Just D? Okay. So yeah, this is, it's challenging because all of these are the exact same domain, right? They're all example.com. They're actually all different origins. The answer is B only. The only thing that JavaScript can talk to, right, origin-wise, has to match on all three of these parts. Must be the exact same scheme. Has to be HTTPS. So that eliminates C, which is HTTP. The host has to be the exact same, and that includes the subdomain. So api.example.com is actually a totally different origin because it's api.com or API instead of www. And then the port also must match. So E goes out because that's 8443, whereas the default is 443. So important distinctions when you're start learning about same origin policy and implementing this. And so how is JavaScript loaded from an origin? When I say, we talk about if it's loaded from the origin, it can talk to the origin, but what does that actually mean? Well, it really just means that the JavaScript has to be included somewhere in the HTML that was returned from that server, from that origin. So normally it's in a script tag, right? You can just do like script source equals, and you load and execute the JavaScript. But it can also be in a lot of other areas like HTML attributes. So this is an example code. I'm loading JavaScript that says hello 4 different ways. Loading it from the same server, from a different server. I'm clicking a button that executes JavaScript, and I am trying to load a bad image that spits out an error, and the error is JavaScript. All 4 of these have executed JavaScript in the origin, but as you can see, there's a lot of different like subtle ways that you can get JavaScript to execute. So kind of in summary here, that was our back to school quick web 101. Understanding web security requires understanding those concepts of HTML, HTTP, JavaScript, but really importantly, what the browser just does for us by default, why same origin policy exists and why it's important, why cookies exist and why they're important, because all of the vulnerabilities that we're going to talk about exploit the way the browser handles those. You can kind of break security concerns into 2 categories, client side or server side. So as attackers, if we're attacking a web app, we're either attacking the clients, we're attacking the browsers of the users of the people who are using the website, or we are attacking the server that's hosting the website. kind of very akin to like the back end versus front end development, right? Django versus React. There's going to be vulnerabilities that exist within Django. There's going to be vulnerabilities that exist within React. We're doing back end vulnerabilities and front end vulnerabilities. And as developers, you know, you're already way ahead of most security professionals in understanding these concepts, to be honest. I have taught this type of material to like pen testers, and they don't have the web development experience. They actually haven't built web applications, so they don't understand that piece of it. So I actually think it's easier sometimes, or most times, to teach security on top of web development than it is to do the other way around. So you guys are already way ahead of the curve here by already knowing, you know, some Django and knowing some React and knowing how to build these together. We can add the security on top of that pretty easily, hopefully. So I mentioned the OWASP, the OWASP top 10. The OWASP top 10 is a list of vulnerabilities that's curated and published every 4 years, where OWASP as the foundation goes out, does a lot of research, looks at the state of security, and publishes their top 10 web application security risks. And it's not an exhaustive list. There's way more than 10 vulnerabilities out there, but this is just kind of a way to see where we're at with web application vulnerabilities. And then OWASP also publishes cheat sheets and remediation guidance for all of them. So this is the OWASP top 10 published in 2017. So it's due for a refresh in 2021. But these are the top 10 web vulnerabilities. We have injection, broken authentication, sensitive data exposure, XML external entity injection, broken access control, security misconfiguration, cross-site scripting, insecure deserialization, using components with known vulnerabilities, and insufficient logging and monitoring. A couple of notes, injection has been #1 on the OWASP top 10 since the OWASP top 10 was very first released in the 90s. It has never moved from the #1 spot. So we're definitely going to be talking about injection. That's the #1 biggest risk to web applications. Cross-site scripting, I think, has always been on there as well, although the number has kind of moved up and down. So cross-site scripting, again, a very super important vulnerability. There was a couple new ones in 2017 that kind of showed the way that times are changing and there's some more advanced attacks out there. So XXE and insecure deserialization were brand new in 2017. And also cross-site request forgery, or CSRF, for the first time since the inception of the top 10, dropped out of the top 10. But I'm still going to talk about cross-site request forgery because it's common enough and important enough to know. Even though it's technically not in the top 10, we still see it all the time. And broadly speaking, you can break these like 10 vulnerabilities down into 2 categories. We can break them down into technical vulnerabilities and design vulnerabilities. And what I mean by that is there's vulnerabilities that are on this list that very explicitly exist within code. They are identified in code and they are fixed in code. And we are fully responsible as we are coding to actually defend against these. The design vulnerabilities are more about how the app is architected or some of the external factors that go into our application. So the design vulnerabilities are actually sometimes a lot harder to spot and harder to fix because we don't exactly know like what line of code they exist on. So it kind of breaks down almost 50-50, where injection, XXE, cross-site scripting, and deserialization are technical vulnerabilities. Those will exist in your code. Things like broken authentication or exposing sensitive data or having like misconfigurations or using open source components, right? Those don't exist explicitly in code. They're more like design considerations. So the last thing I'll mention on that is the design vulnerabilities are actually much harder to spot with automated tools. So as we're pen testing and we're doing manual tests, those are the types of things we need to test for because those, are human errors generally. So kind of think you need to apply some human ingenuity to identify and to exploit them. Okay, so I have been talking for an hour now. That was all the background information, kind of the high-level overview of security and some of the building blocks of web application and web application security. I think I'll pause for a quick break so I can refill my coffee and give everyone a chance to refocus here. I know that was a lot of information I just threw at you, but before I take a quick break, does anyone have any questions or comments on some of the stuff that we just talked about? Cool. So yeah, does that work for everyone if we just take like a 5-minute break, and then what we'll get into is actually like manual testing and finding these vulnerabilities and exploiting them, what they look like. Does that sound good?
That's good. Hey, Ronnie, I was actually thinking, what are some of the other protocols that are in use besides HTTP that might be only used maybe within certain industries? Or is that something that's common?
Yeah. So for web applications, there's a limited subset of protocols that are there. HTTP is the big granddaddy of them all. But you will definitely come across WebSockets. If you've heard of them or done anything with WebSockets, like those are becoming extremely more common for real-time communication. One of the drawbacks of HTTP is it's asynchronous. So like the server sends something and then waits, and then the client sends something and waits, and they don't actually like have a stream of data back and forth. WebSockets solves that, so you can open a WebSocket connection and it's like real-time data traveling back and forth. So WebSockets are used in a lot of like real-time or streaming applications. So you'll see WebSockets for web apps. For non-web app security, like you'd mentioned Kali Linux earlier, you'll see a lot of tools in Kali Linux for other protocols that exist on the network. And there's in Windows environments, you've got things like SMB for file sharing, or LDAP, or DNS, or all of these are protocols that exist on the network. But for web apps specifically, the protocols you'll see, I guess I should have mentioned DNS. You'll see DNS to look up where your web server is. But once the web server is loaded, it's going to almost entirely always be HTTP and or WebSockets.
Okay. Very cool. Thank you.
Yeah. Good question.